Hi, my name is Tori Heckart, and today I want to talk to you about the research I've been doing at the Colorado School of Mines. With the help of my mentor, Erica Clevenger, and research advisor, Dr. Chris Bellona, I am trying to optimize biofiltration for water reuse purposes. But don't worry, we'll get into what that really means in a bit. To start, I first want to talk to you about water scarcity here in the United States. While the average American is using less water due to conservation efforts, population growth and shortages in water supplies continue to put pressure on dwindling resources across the country. For example, the Colorado River supplies water to millions of people, but in the last 20 years has lost approximately 1.5 billion tons of water due to the climate crisis. Water is essential not only to our daily lives as individuals, but it's also important to all of the industries we rely on, and therefore irrevocably is tied to our economy. So, how do we address this? One method for supplementing water supplies is reuse, and we already do this whether you realize it or not. We're reusing from the communities upstream of our own water resources. This is called indirect potable reuse, which basically means we're using recycled water with some sort of environmental buffer. But a more efficient means of recycling water is direct potable reuse, which is when stormwater or wastewater is treated and used for drinking water without an environmental buffer. The treated water is introduced directly into a potable water supply system or into the raw water supply immediately upstream of the treatment plant. This technique is a solution with the potential to improve both the sustainability and reliability of potable water supplies. One technology of particular interest for DPR treatment is biofiltration, which is a filtration technique that uses living material to capture and biologically degrade pollutants. Basically, microbes help eat up all the bad stuff. Biofiltration is extra advantageous because it incorporates two main mechanisms of removal for contaminants. There's biological treatment, where little microbes eat away at stuff, and then there's absorption, where contaminants are trapped by the surface of the filtration materials, and then it becomes easier for the microbes to eat those contaminants. Additionally, biofiltration is simple to construct, robust, energy efficient, and requires fewer chemicals than other treatment techniques. So now that we know all about water scarcity, how reuse can help us solve it, and how fantastic biofiltration is, let's get into the questions my team and I are looking to answer. We want to know how to optimize biofiltration practices for source water treatment, which is really a fancy way of asking, how do we keep the microbes happy? We want to know what the microbes like to eat. Is it nutrients, COD, something else? Then we want to figure out what kind of environment the microbes like. What's a good pH? How much dissolved oxygen should there be? Does temperature affect their performance? Stuff like that. And by answering these questions, my goal is to find the best way to start and operate a biofiltration system. The world is changing, and water supplies are becoming more and more scarce every year. But hopefully projects like this one can help to advance direct potable reuse as a reliable and sustainable way to provide everyone with clean, potable water. However, biofiltration is not the only piece to this puzzle, and it's going to take a lot of bright minds to compile all of the different solutions to the problem of water scarcity. Thank you!